This is a very short lesson or introduction to Descartes' rule of signs. And that is really just going to help us to narrow down what are the types of solutions that we could have for any given polynomial. So the number of positive real solutions is either the same as the number of sign changes in f of x, which means we're just going to look from one term to the next, did the sign change? Nothing tricky there. It's either the same as that or less than that. But it's always going to be less than that by a positive even integer, so taking 2 away or taking 4 away, etc. The number of negative real zeros, same idea. It's if we plug in a negative x, so we're going to rewrite it by plugging in a negative x and then count the sign changes there. So let's try one together. So the first thing I'm going to do is I'm going to look at the sign changes from x to the 5th to negative x to the 4th. That is a sign change. From negative x to the 4th to negative 14x to the 3rd, not a sign change, but this one is negative to positive, positive to negative, that's another sign change, and then negative to positive, that's another sign change. So the number of possible positive real zeros is 4. I know total, how many do I get? I only get 5. Okay, so am I going to have a 1 here or a 1 here? I don't know. Now, could I possibly have a 1 on imaginary zeros? No, not a trick question there. We talked about the fact that if you have an imaginary, you also have its conjugate. So I know for sure that this is going to be a 0 and this is going to be a 1. But let's go ahead and use Descartes' rule of signs to prove that it will in fact be 1. Let's take this function and I'm going to replace x with negative x. So if I put a negative x in here, that would give me negative x to the 5th, because if I took a negative 5 times, the solution would be negative. If I plugged a negative in here, this is not going to change because this is x to the 4th, so negative x to the 4th would still be positive x to the 4th, so this is still exactly as it was. So really it's only going to affect any of the odd ones. So this one's going to go from negative to positive 14x cubed. This even one's going to stay exactly the same. This one is odd, so it's going to change signs. This one is going to stay exactly the same. And now let's count up those sign changes again. Negative to negative, not a sign change. Negative to positive, that does change signs. Positive to positive, positive to positive, positive to positive, so it's just 1. So this is 1. And I can't go down 2 from there, obviously. So that means that it could be 4 and 1 to add up to 5. It could be 2 less than this, so 2, 1, and 2, which again adds up to 5 because they have to add up to 5 because that's all of the solutions. And then it could be 2 less than that, which is 0, which means there would be 4 imaginary solutions, again adding up to 5. So we found this number, and then remember we can decrease it by 2, decrease it by 2, and the way that we do that is because this is increasing by 2. Try this one on your own and then press play to check your work. Again, starting off here, we know it should be adding up to 5 at the end. So let's take a look from here to here. This is not a sign change. This is not a sign change. This is not a sign change. So 0 of those. Plugging in negative x, that would give me a negative 4x to the 5th because an odd is going to change signs. An odd is going to change signs. An even is not. And a constant is of course not. So from here to here, negative to negative, this is a sign change. This is not. So it's 1 negative, which means there has to be 4 here. Now, could I put a 2 here? No, because I'd have to decrease it by 2. I can't decrease 0 by 2. So the only option here is right here. I'm not going to have any positive real zeros. I'm going to have 1 negative real zero, and I'm going to have a bunch of imaginary solutions. Now, why do I care? Why do I do this? Just for fun? No, because now when I'm looking at my PQs, if I'm trying to actually factor this, I know to not even try any of the positives at all because they're not going to work. So that just cut my work in half. I'm only going to plug in my negatives to find one of them, and then the rest of them are just going to be imaginary anyway. So that's how this rule will help us so that we don't have to do as much work at the end.